Last year, we talked about number systems because we talked about rational numbers, and we did some work with rational numbers last year. This year, we're also going to focus on something called irrational numbers. You actually know an irrational number, and it is pi, and we'll talk about it in a second. So just to review the number systems, we have the natural or counting numbers. Okay? So those are the numbers that we use to count. We call them capital N, and they consist of the numbers, well, starting at 1 and going up by ways. That's it. The next number system is the whole numbers, which includes all these numbers, but one more number. And that is 0. So every whole number is made up of all the natural numbers and 0. Well, those aren't the only numbers that exist. So we got another set called the integers, which are made up of all these and negatives. And we actually use the letter Z. I know it seems weird that we don't use I, but I actually stands for something else in that. And how we write this is, okay, well, we have to kind of do it like this. We put 0 in the middle, and then we count up forever, 1, 2, and so on. But then we also count down into the negatives, negative 1, 2, and down forever. So that's what it looks like in notation. Like I said, last year we talked about rational numbers. And rational numbers, we actually use the letter Q. Okay? But I can't write it in notation like this because it's impossible. Like, what's the next rational number after 0? Well, rational numbers are any numbers that can be written as fractions. So what's the next fraction after 0? Some really small number. But then what's the next one after that? So it's impossible to list them. So the best we can do is we can say any number that can be written as a fraction. So like A over B, where A and B are integers, positive or negative whole numbers. And B, and that notation is cannot equal 0, because we can never divide by 0. So A and B can be any integers except B can't be 0. So what do all these numbers include? All the ones above. Because I can write all these numbers above as fractions. So as examples, I could write 7 is a rational number, because how would you write 7 as a fraction? 7 over 1. -10 is a fraction, because again, you can write that, or sorry, -10 is a rational number, because you can write that as the fraction -10 over 1. Obviously, any fraction is a rational number. So pick a fraction and it's a rational number. And any decimal, because decimal is just another form of fraction, that ends or repeats. So like any decimal could be -0.57, because that can be written as a fraction, -57 over 100. What I mean by repeats are ones like this, 0.3, and then with the bar over the 3, which means that the 3 keeps going forever. Because that can be written as the fraction 1 over 3. Well, if rational numbers are any numbers that can be written as a fraction, what do you think irrational numbers are? They can't be written as a fraction. And we use the notation, the letter Q with a bar over it. Cannot be written as a fraction. Which means it's not any of the above numbers. Okay? Or it's a decimal number that never repeats and never ends. Can you think of a number that never repeats or never ends? Pi. Because it's 3.14159, goes on forever. We have no idea what the last digit is. Okay? Any square root of a non-perfect square. So if we start at 1 and start taking square roots, well, the square root of 1 is rational because it's 1, which can be written as the fraction 1 over 1. The square root of 2, well, you can't do it without using a calculator. And when you use your calculator, you get this long decimal answer. That decimal answer actually never ends or never repeats. Okay? Same with the square root of 3. What about the square root of 4? Rational or irrational? Square root of 4. Why is it rational? You're right. Because it's 2, which is the same as 2 over 1. Okay? So things like square root 2, square root 3, square root 5, 6, 7, 8, but not 9. Okay? You don't have to memorize these definitions, but you should understand what I'm talking about if I refer to a rational number and an irrational number. So really, when I say rational number, you should be thinking fraction, thinking that word. Like last year, we solved rational equations, those fractional equations where we multiplied by the LCD. Okay, before we go about there, let's actually do this example first. So you're given numbers and you're asked if they're rational or irrational. What's A? -3/5. Rational, because it's a fraction. Obviously, a fraction can be written as a fraction. So that's easy. Square root of 14. Irrational. Because it's not a perfect square under the square root. Which means that if you take the square root, you're going to get a decimal answer that never ends or never repeats. How about this one? Rational. Why? Yeah. Because this equals 3, which can be written as the fraction 3/1. Okay. All those previous number systems on the first page, we can show using a diagram. And we start with the innermost oval. This is where all the whole numbers are. Or sorry, not whole numbers, pardon me, natural numbers. So 1, 2, 3, 4, etc. Remember I said all the natural or counting numbers are all whole numbers, but also 0. So that's why we put W here. Because the whole numbers are all the natural numbers and 0. The next one I put are the integers. Because the integers are made up of natural numbers, whole numbers, and negative numbers. Remember I said all of these can be written as fractions, so they're all part of this big circle. And anything that can't be written as a fraction has to be outside the oval, so all the irrational numbers are here. In the rectangular area, but outside the Q oval. So where would I put, in what oval or in the rectangle, would I put the number -7? Where would you put it? In the Z, but outside these, right? Next, so -7. Where would I put the number 0.6? Well, it's obviously not one of these. It's not one of these, it's not one of these. Can I write that decimal as a fraction? Yes. So it's here. It's in the Q oval, but it has to be outside the N, W, and Z ovals. Where would I put 0? In the W, but outside the N. Where would I put the square root of 9? Careful with this one. Q. What is the square root of 9? Oh, come on. It's 3. And isn't that a counting number? So it's down, it's way down in here. Oh, sorry, I said square root of 9. Where would I put the square root of 10? Sorry?
I don't know.
I can't hear you. Okay, well, never mind. Anybody? In the irrational, right? Here. Because it can't be written as a fraction. 3/7. Rational in Q, but outside Z, W, and N. Okay, so you sort of get the idea. Okay, the last example. You're asked to take these 4 irrational numbers, sorry, they're not all irrational, and order them from smallest to largest, or least to greatest. Will any of these numbers give you a negative answer? Yeah, this. Okay. Because what times itself gives you -5, some negative decimal. Because negative times negative is positive, times negative is negative. This is the only one that gives you negative. So this has to be the smallest. Has to be. Because the other ones are all positive. So they have to be bigger. Well, you can tell me what this one is. Square root of 9? 3. So we know that's 3. Remember last year we estimated square roots? Where would this square root of 18? What perfect square is close to 18? I heard somebody say it. 16? Yes. And we know the square root of 16 is 4, right? So doesn't the square root of 18 must be 4 point something? We have no idea. And it doesn't matter because we're only listing these from largest to smallest. So I know this is bigger than this. So square root of 9 or 18 is bigger than the square root of 9. Question is this one.
9.
Cube root of 13. What perfect cube is close to 13?
10.
10 is not a perfect cube. Okay, think of your perfect cubes. How do you find perfect cubes? 1 times 1 times 1. 2 times 2 times 2. What's 2 times 2 times 2? 8. So what's 3 times 3 times 3? 27. So doesn't this have to be between 2 and 3? Because it's bigger than cube root 8, but it's smaller than cube root 27. So it's 2 points. We don't know, and we don't care. So now I can get the smallest to the largest. This one is the smallest of those 3 positive numbers. This one, square root 9, is next. And square root 18, which is 4 point something, is the largest of those less. So there's our list, smallest to largest. And notice we were able to do that without a calculator. You could have also used a calculator and punched in everything and then just compare there. Okay. Okay.